This is problem number 9 from section 5.1. It says given f of x equals 3x plus 4 and g of x equal root 9 minus x squared, find each of the following. Identify the domain of each. So we're going to do f of g of x first. So let's go ahead and start part A here. Say f of g of x. That's going to equal f with an input of g of x, which is going to equal f with the input g of x is root 9 minus x squared, which is going to equal, we're going to take 9 minus x squared and we're plugging in for x here. So we get 3 root 9 minus x squared plus 4. So our expression is this here for f of g of x. What's the domain? Well, the only issue I have for our domain is I can't take the root of a negative. So if I set the inside of this 9 minus x squared so that I would have to have 9 minus x squared, essentially the solution to be greater than or equal to 0, I should be able to solve that then. So let's do that here. We're going to say 9 minus x squared has to be greater than or equal to 0. Now remember, this is a inequality, a quadratic inequality. So the first step I'm going to take here is I'm going to set this equal to 0. So I'm going to say 9 minus x squared equals 0. And I'm going to kind of write this sideways so I save room. So I'm going to add the x squared over. So that's 9 equals x squared. Take the square root of each side. So I get, when I take the square root of x squared, that's just x. When I take the square root of 9, I get plus and minus 3. So my roots are plus and minus 3 for this. So I'm going to go ahead and mark on my number line -3 and 3. Now remember, I'm plugging in a number outside here, inside here, and outside here, trying to figure out what are my possible input values that work. So all I've got to do is take -5 and store it as x, and then write in 9 minus x squared. And if it's greater than 0, it works, but it's not. It's -16, which is less than 0. So this area does not work. I'm going to kind of X that out. I'll use a different color so we can see it's a little different. All right, and then we're going to plug in 0. So 0 stored as x. Grab the function. I get a positive. So because it's equal to, we can put a bracket here and a bracket here. And then now we're going to check 5. So 5 stored as x. And then we're going to go up and grab this. Negative, so this area does not work. So this is telling you that your domain values have to be between -3 and 3. So the domain is all x values from -3 less than or equal to x less than or equal to 3. Now let's go to part B. And the reason that that's the case is because of the radical. Part B. We've got g of f of x. So that's g with an input of f of x. So that's g with an input of, we're going to say 3x plus 4 because that's what f of x is. which equals, when I plug 3x plus 4 in, to this g function for x, I get root 9 minus 3x plus 4 squared. Now inside here I should do a little algebra. So I'm going to say that that equals root 9 minus, this would give you 3x plus 4 times 3x plus 4, which is equal to root 9 minus, this will be 3x times 3x, which is 9x squared, 3x times 4, which is 12x, 4 times 3x, which is also 12x, and 4 times 4, which is 16. Now I can distribute that negative at the same time that I combine this. This will be 24. So I end up with root 9 minus 9x squared minus 24x minus 16. I combine these together, 9 and negative 16, and I'll end up with negative 7. So I get negative root negative 9x squared minus 24x minus 7. Now it wants to know what's the domain. So you could have probably left it like this. I would accept this as an answer. This would be okay. But this is a good answer as well. But for the domain, we're going to need to take the inside of this and set it equal to 0 or greater than or equal to 0 to figure out, okay, what x values work inside here. So we're going to say, because we can't take the root of a negative, so that's why I said greater than or equal to 0. So we're going to say negative 9x squared minus 24x minus 7 has to be greater than or equal to 0. First step when I solve these is to set this now using an equal sign. And then I'm going to use the quadratic equation here, the quadratic formula. So the quadratic formula, if you remember, negative b plus and minus, so on and so forth. So we're going to have x equals negative 24 plus and minus root, this will be negative 24 squared minus 4 times negative 9 times negative 7. All over 2 times negative 9. So x is going to equal, we're going to try and plug as much of this in the calculator as we can. Negative 24, we're squaring it, minus 4, negative 9, negative 7. Gives you 324. Let's do the square root of that. That gives you 18. So I end up with 24 plus and minus 18 over negative 18. So let's start to simplify this now. So this is going to be x equal 24 plus 18, which would be, let's see, 24 plus 18 is 42. Yep. 42 over negative 18. Let's see if we can simplify that quickly. So 42 divided by negative 18. We'll get the fraction, negative 7/3. Or x equals, we subtract the 18, that's negative, or that's 6. So we get 6 over negative 18, which is negative 1/3. All right, now we found our roots, so now we need to check. Now we need to check using a number line where our domain lies. So I'm going to get a new sheet of paper out here. I'm going to slide this up a lot. Okay. Draw the number line. Mark -7/3, which is a smaller number, right? Mark -1/3. And we're going to pick a number, -7/3, that's actually like more or less than, that's -2.33, I think. So we're going to pick, let's pick -5 out here. We'll pick -1 because that's in the middle here. And then let's pick 0 out here. All right. Now, again, we're using this function, which I'm going to write again right here. This function we're checking is -9x² minus 24x minus 7 greater than or equal to 0. So I'm going to plug in my calculator. I'm going to plug in -5, store it as x. I'm going to type in this function here. So I'm going to say -9x² minus 24x minus 7. And if it's greater than 0, it works, but it's not. So we're going to cross that area out. -1, store it as x. Grab the function again. That's positive. That's bigger than or equal to 0. So we're going to, because it says greater than or equal to, we're going to bracket here and here. And finally, we'll plug in 0. Now, I don't even really need to plug it in. 0, when I plug it into this function, cancels out these two terms. -7 greater than or equal to 0, that doesn't work. So I'm going to put a cross there. So my domain has to be all reals. Actually, we're not even going to say our domain has to be, well, we could say all reals between x, how about between -7/3 less than or equal to x less than or equal to -1/3. So all reals between these two numbers, -7/3 and -1/3. So our domain is this. If you look from earlier, we had this was our expression that we got. So now all we have to do is we have to do f of x. So I'm going to go ahead and write f of x here. And I'll write the two functions that we've got. Well, actually, we only need the one. So f of x is 3x plus 4. So we're going to say that f of x, and this is part C, is f with an input of f. So it's f with 3x plus 4 input in. We're going to plug the 3x plus 4 in for x. So we end up with 3x plus 4 plus 4. We distribute there and we end up with 9x plus 12 plus 4, which is 9x plus 16. I'm kind of relieved here because guess what? That's a polynomial, so the domain we don't have to do near as much work for. The domain of this is just all reals. Hallelujah. And that's how you find the domain when you're doing composition of functions.